Assalamualaikum. My name is Muhammad Ashraf Daniel. My number metric DD 250031. This is an intro for our case study. Static is the fundamental branch of engineering mechanics that study rigid bodies maintained in perfect equilibrium under the action of force and moment. This project applies the concept of 2D equilibrium of rigid body as covered in chapter 3 of the course syllabus, using a straight-line pole frame and L-shaped rigid assembly consisting of a vertical pole, horizontal arm and inclined brace, commonly found on roadside and campus as the case study, supported by a fixed base and a 2 force member and subjected to load such as lamb weight, self weight and point force. The structure must satisfy all 3 equilibrium conditions to remain safe and stable without any translation or rotation. This is our objective. First, draw correct free body diagram FBD for the frame. Second, apply equilibrium equation to find reaction at base A and force in brace BC. Third, verify that the rigid body equilibrium principles are satisfied. 4. Use AI as a review or check tool while ensuring manual verification.
Statics is one of the most fundamental subjects in engineering mechanics. It deals with the analysis of bodies that remain at rest under the action of external loads or external forces. In this study, the straight-line structure is assumed to behave as a rigid body, meaning that any deformation is considered negligible. For a structure to remain stable, it must satisfy 3 equilibrium conditions. First, the sum of all horizontal forces must equal to 0. Second, the sum of all vertical forces must equal to 0. Finally, the sum of all moments acting on the structure must equal to 0. These equilibrium equations are essential because they allow engineers to determine unknown forces and support reactions, ensuring that a structure can safely carry the applied loads. For 2.2 application in straight-line structures, the selected case study is a straight-line support structure. Although it appears simple, it represents a real engineering application that can be analyzed using statics principle. Straight-line structures must remain stable while supporting external loads. In this design, a diagonal support member is added to improve stability and reduce bending effects on the horizontal beam. Similar structure configurations can be found in highway signboards, telecommunication towers, cantilever supports, and industrial structures. Therefore, understanding the force distribution in the structure has practical engineering significance. 2.3 Free body diagram. The free body diagram or FBD is one of the most important tools in statics analysis. An FBD shows all external forces acting on a structure after it has been isolated from its surroundings. For our structure, we identify a downward load of 600 newtons, a downward load of 800 newtons, the force in member BC, and the support reactions at point A. By identifying these forces clearly, we can formulate the equilibrium equations required to solve the problem. Without a correct FBD, the entire analysis may become inaccurate. 2.4 two force member theory. Member BC is classified as 2 force member because forces act only at its 2 ends. According to statics theory, a 2 force member can only carry axial forces, meaning it experiences either tension or compression. The geometry of member BC forms a right triangle with a horizontal distance of 2 meters and a vertical distance of 1.5 meters. Using the Pythagorean theorem, the member length is calculated as 2.5 meters. From this geometry, we obtain the sine and cosine values required to resolve the force into horizontal and vertical components during the analysis. For 2.5 moment equilibrium and structural stability, besides force equilibrium, moment equilibrium is equally important because a structure can fail due to rotation even if the forces are balanced. A moment is calculated as the product of force and perpendicular distance from the pivot point. In our case study, the two downward loads creates moments about the support. The diagonal member BC helps resist these effects by transferring part of the load through axial force. As a result, the structure becomes more stable and experiences reduced bending effects. For 2.6 Previous studies and engineering references support the use of statics principles in structural analysis. According to Hibbeler, equilibrium equations are fundamental tools for determining support reactions and internal forces. Beer and his co-author emphasized the importance of free body diagrams and two-force member analysis in solving engineering structures. Research also shows that bracing systems, such as member BC, significantly improve structural stability by reducing bending moments and distributing loads more effectively. For 2.7 Significance and objectives. This study is significant because it demonstrates how fundamental statics concepts can be applied to a real engineering structure. The objectives of this study are to analyze the straight-line structure, construct the free body diagram, determine the force member in BC, calculate the support reactions, and evaluate the stability of the structure under the applied loads. Point 3. Forces and boundary conditions. For this analysis, two external loads are applied to the structure. The first load is 600 newtons acting downward, while the second load is 800 newtons acting downward at another location on the beam. Point A is modeled as a pin support, which provides horizontal and vertical reaction forces. Member BC is treated as a two-force member, meaning its force acts only along its axis. 3.4 Critical parameters. Several parameters influence the behavior of the structure. These include the magnitudes of the applied loads, the geometry of the structure, the angle of member BC, the location of the loads, and the type of support load. Any changes to these parameters will affect the force distribution and support reactions throughout the structure. 3.1 Description of the case study. The selected structure consists of a horizontal beam connected to a vertical support and reinforced by a diagonal member BC. The vertical support has a height of 1.5 meters, while the horizontal distance between points A and B is 2 meters. The entire system is modeled as a two-dimensional rigid body and analyzed using equilibrium principles. For 3.2 Engineering problem statement. The main engineering challenge is to determine the force acting in member BC and the support reaction required to maintain equilibrium. Since the loads generate both forces and moments, it is necessary to apply the equilibrium equation systematically. The solution will help verify whether the structure is capable of safely supporting the applied loads. Point 3. Forces and boundary conditions. For this analysis, two external loads are applied to the structure. The first load is 600 newtons acting downward, while the second load is 800 newtons acting downward at another location on the beam. Point A is modeled as a pin support, which provides horizontal and vertical reaction forces. Member BC is treated as a two-force member, meaning its force acts only along its axis. 3.4 Critical parameters. Several parameters influence the behavior of the structure. These include the magnitudes of the applied loads, the geometry of the structure, the angle of member BC, the location of the loads, and the type of support load. Any changes to these parameters will affect the force distribution and support reactions throughout the structure. For the last but not least, assumptions and expected outcomes. In this study, several assumptions are made to simplify the analysis. The structure is assumed to be rigid. The safe weight of the members is neglected. All connections are frictionless, and the loads are considered static. The expected outcome is to determine the force acting in member BC, calculate the support reactions, verify the equilibrium conditions, and demonstrate how the diagonal member contributes to the stability of the structure.
Assalamualaikum, my name is Muhammad Shahmi and I will explain about the mathematical modeling. For the first one, we need to draw the free body diagram. As we can see here that I already labeled all those forces and reaction. For the forces, there are three forces that include in the body diagram. The first one is load structural as the weight of the beam itself. The fixture weight as the weight for the light and forces at FBC. And then the reaction is, we can see that at point A, it was support. So it can be moved in x-axis and y-axis. So you will have the FAX and FAY. Okay, for the equilibrium equation, which is calculation, is a step 1. Moment equilibrium at A. To find the strut force at FBC, we take sum of the moment about pin A. So eliminate reaction FAX and FAY. So the moment at point A is equal to 0, equal to negative 600 multiplied by 1 minus 800 multiplied by 4 and positive FBC multiplied by the sin theta, which is 1.5 divided by 2.5 and multiplied by 2. So we could get the FBC equals to 3166.67 Newton. For the step 2, vertical force equilibrium. Since we have the FBC, we can use the equilibrium for Fy equal to 0. So with that equation, we could get Fy equal to negative 600 plus the FBC itself, which is 3166.67 divided by sin theta 1.5 divided by 2.5 and minus 800 and minus FAY. So with the equation, we could get the FAY equals to 500 Newton. Finally, we balance the horizontal component to find the horizontal reaction at support A. For the step 3, we use the horizontal force equilibrium, which is Fx equal to 0. And then at Fx, we could get Fx minus FBC cos theta, which is 2 divided by 2.5. And then we could get the Fx equal to 2533.34 Newton. Okay, for the next one is for assumption and limitation. For assumption, there's a 3 point. The first one is rigid body behavior. The main horizontal beam and the supporting strut are considered perfectly rigid bodies. As we can see, rigid body is an idealization of a solid object in which deformation are completely ignored. For the second one is backlash strut. The weight of the diagonal supporting strut BC is assumed to be negligible compared to the large external force, allowing it to be treated strictly as an ideal two-force member. As we can see here, in the real life, for the strut BC itself, it will have downforce that will downforce for itself. So in this case, for the equilibrium of a rigid body, we completely ignore the load at the strut BC, which means the strut BC is perfectly straight. For the third one is static loading. The load structural and fixture weight are assumed to be static point, loads that don't change over time, which means that it will stay 600 Newton and 800 Newton no matter how long it takes. Okay, for the limitation, dynamic exclusion. This model is strictly limited to static equilibrium analysis. It completely excludes dynamic environmental factors such as wind-induced vibration, aerodynamic, aerodynamic drag or seismic loads, which is that over time we will not consider that all those parts that included will move or have a motion itself.
Assalamualaikum. My name is Muhammad Azim Bima Adam, metric number DD250053. Today I want to talk about comparison and selection method to calculation. Moving our mathematically strategy to solve our unknown support forces with high accuracy, we evaluate two methods. We have a use strategy 1, which is we setting up the horizontal and vertical forces equation first. Like we find Fx and Fy first. To doing this, increase the high risk of the calculation surrounding error propagating through the entire model. Instead, our team selected, we choose to method number 2, which is focus on the couple moment pivot and about point A by placing our pivot point directly at the point at the hinge support. The line of action for above unknown base forces pass exactly through the point A. By preventing error propagation, a strategic method number 2 gives us the much more reliable and robust mathematical model to our final calculation. You can see at the previous slide, my friend present about we use the equation. First equation is moment, sum of moment equal to 0, and then we find the Fax and Fay. After that, I want to talk about summary of structure action. For the structure FBC, the structure are compressed into the arm. For the Fax, the forces go the rightward. For the forces at AY, the forces go to downward. And then I want to talk about discussion. We have a 3 main point of discussion. Point number 1 is a load path and overturning moment. The total downward load consists the 6 Newton mid-span weight and 800 Newton tip weight. So the total load downward is 1400 Newton. For the overturning moment, generate a clockwise rotation action of 3800 Newton meter about a point A. The support mechanism are required to the external counter moment to prevent downward structure rotation. For the point 2, brace BC behavior. Support forces type experience to the major internal compressive force of 3.16 kN outward push component. They provide the vertical lifting force of 1.9 kN at the point B. So we successfully balance the clockwise overturning moment to achieve sum of moment. For the last point is a very important. It is joint safety and quality control check. The material restriction. We must to use a solid structure steel to prevent a comprehensive bulking. And then design goal. We need to choose the right size bolt to the joint to withstand this combined shear load. That's all. Thank you.
Conclusion. Our case study successfully applied to the rigid body equilibrium principle to analyze a straight light pole frame, a common real-world rigid structure. Constructed free body diagram and solve the 3 equilibrium equation: sigma Fx equal to 0, sigma Fy equal to 0, sigma Ma equal to 0 to determine all unknown. First is axial force in brace BC. Total is 3166.67 compression. Number 2, reaction at pin A, 2533.34 Newton. positive 500 Newton to negative. Verified the structure meet full equilibrium condition, no translation, no rotation, under applied load of 600 Newton and 800 Newton. Demonstrate key concept: two force member, reduce bending and improve stability, and idealize support pin joint, simplify analysis while representing real behavior. Confirm that Chapter 3 static principles are directly applicable to everyday structure. Equilibrium analysis is the fundamental first step in design. AI used as supporting tool for theory review, equation drafting and checking, all results manually verified to ensure accuracy and understanding. Proof clear link between textbook theory and practical application. Rigid body equilibrium directly govern the safe design of straight light frame.